Great, so I think we can get started. Welcome everyone. Thank you for joining us in this breakout room on inductive charging infrastructure. In a few minutes, we'll hear some enlightening presentations, but I would like to just take a minute to introduce our two speakers that we have here. First off, we have Sergio Perez, who is the Sales and Business Development Manager of e-mobility at IPT. Sergio is a civil engineer and doctor in transport infrastructure with more than 15 years of experience in urban mobility infrastructure and pavements as a developer and researcher and designer, and is highly committed to the development of transport through practical and smart solutions. And he is leading the development of the Inductive product with UZG, which this session will look at. And we also have Silvia Valero from the Sustainable Mobility Services at the Metropolitan area of Barcelona. Her department oversees promoting and implementing solutions to transform mobility in a more sustainable way in the whole of the metropolitan area of Barcelona. She's previously worked on city mobility, green alternative means of transport, such as ropeways, and has joined the UZG project because of a professional and personal interest. So we'll get the session started with a quick presentation from Sergio explaining this inductive charging system. And then we'll have about 10 minutes for questions from the audience. So please, if you have any questions that come up as the presentation goes along, post them in the chat and we'll be sure to bring them up shortly afterwards. Following this, then Silvia will present Barcelona's approach to inductive charging and will explain how it can help solve some mobility-related issues in the city. And again, this will be followed by a round of questions, so please do post those in the chat. Let's get started then. Sergio, you have 10 minutes and the floor is yours.
Yes, thank you, Fraser. Do you hear me in this moment?
Yes.
Correct. And you see my screen?
Correct, yes. Go ahead.
Okay, perfect. Thank you, Fraser. Good morning, everyone. I'm Sergio Perez from IPT, and I'm presenting you today, as mentioned by Fraser, the current workshop about the inductive charging infrastructure for e-vehicles. And first of all, I would like to present very briefly our company and some aspects and principles of the inductive transfer technology for everyone to be aligned and know more about it. So first of all, IPT is a company that has been active for more than 20 years in this technology or wireless power transfer domain. The first area of work has been the industrial and logistic world, but IPT has been also doing inductive charging for e-buses since 2005. And now with the acquisition of the brand Primof from Bombardier, IPT has decided to develop more strongly the e-mobility solutions. In this slide here, I wanted to show you some short examples of applications where you can find the wireless charging in the industrial level. You will have all sorts of machinery moving with cables that are embedded on the floor and which are transmitting through the air continuous charge for continuous energy for the machinery that is moving in an industrial site. And in the e-mobility, you have also in the pavement or sometimes in the harbor, in the pontoon, a solution for inductive charging, which will be static most of the time, but there is also the opportunity to do in these pavements a dynamic charging. So as experts in the technology, IPT has been working 15 years in the e-mobility area, installing systems in more than 50 public electric vehicles and having more than 15 charging stations. So to go further in the most important point is the wireless principle. In this slide, you can see a short explanation of this wireless charging principle. All comes from the standard principle in a transformer where the iron core has been divided and the gap between the windings has been enlarged. The last smart action is to elongate it on a pavement surface, for example, and in order to have a proper area providing enough magnetic field to be able to charge any vehicle. So it's this last step which is bringing us to the e-mobility, and it can be very versatile as long as it can be in a static way to in a point to be charging in a punctual position, or in a dynamic street where you will charge dynamically by putting this all the way along the street. In this slide, you can see the typical infrastructure for opportunity charging for electric buses that we have been installing in IPT, and that came also with the brand Primo from Bombardier. The system is mainly composed of electronics that will be in place on the side of the street, for example, here in the footpath in the number 1. And then you have a slab where you have integrated the coils or windings in the number 2. And then this is all the parts with a cooling unit that might be necessary, but depending on the weather conditions. And this is all you have for the part of the infrastructure on the wayside, so to say. And in the bus, you will have the same windings that you have in the pavement to receive the energy, as I mentioned in the principle of gathering together two coils that are where the energy is transmitted through a magnetic field. You need a rectifier, then the number 4, to properly send this energy to the batteries, number 4. Finally, you have also a communication system to manage the whole system itself. So now that I've presented you quickly then these principles and company which is behind, I would like to now in the second part of this workshop present you the developments done in the domain of the private vehicles inside the user-she project. IPT has been developing inside the user-she project charging infrastructure for private vehicles. In the project, this product has the name you can see here in the slide, is Inducar, which means inductive chargings for e-cars. The main target is to design the most user-friendly possible solution by maximizing the potential automation, avoiding, for example, here, the frequent need of handling cables, which most of the time, or many times, they can be heavy, they can be dirty, or sometimes even damaged, or as was for sure presented in the main room, they can also be vandalized, or when you have the plug in, it can be unplugged, and this is also one of the worries you can have. So this inductive system is indeed bringing many comfort to the user, final user, and this is how we think it's a major game changer for the e-mobility. Aligned with the targets of the project, the current challenges for these automotive solutions are of course many. Some of them are here mentioned. Maybe the most important are to combine high efficiency with a compact and light design, because the cars are today very I will say performant, and they have high technology, needing that anything you bring in a car has to be very, very optimized, and the car makers are very jealous with the weight and the dimensions you can bring on. With this, if you want to be automated, you have to develop a position system which can lead into the future to this autonomous parking, for example, and optimize the magnetic field emissions is also something very important, but behind this also the safety features. So all these are some of the big lines I will like to mention first. And now here in this slide, you have the general characteristics of our development inside the user-she. The system for now, as we are starting with the first version generation for private cars, is a 3.6 kilowatt static charger with the main characteristics at system level and component level that you can see here. The characteristics are aligned with the project's complete set of requirements for user-she, for the InduCar product in usership. At system level, you have a product which has a high efficiency as one of our main challenges, fully automatic, needing low maintenance. This is also something already mentioned in the main discussion. Having a duty cycle operation that is conceptually fitting the needs of the operation of the vehicles, with very high technological safety features. As I mentioned, this is a major and key point for the car makers. With, of course, in all his concepts, a very user-friendly approach and robust to withstand the situations on the public areas. In this slide, you can see the main technical characteristics of the particular development we are doing for usership. They are defined in order to be quite optimized for any modern e-vehicle, as I mentioned, in terms of the electric specifications, but also in mechanical level. You can see, for example, here that there is a very high ingress protection. The low weight is also something which was very well thought and optimized. And also the minimalistic dimensions. If you see, for example, the dimensions we are talking about in the car, which is the object that is going in the car is the one in your left, which we call the Oru. It will be as around 30 centimeters by 40 by 2 centimeters. And inside this object, you will have all the technology that is needed to handle in the vehicle the transfer of the energy into the batteries. So that means that the equivalent of the electronics that I mentioned on the number 4 on the bus will be all integrated directly on the coils, beside the coils, in the same object. You can also see one important point here for this 3,6 first generation is that the input voltage is a very low one, or very standard one, better, is the one any of us has in his house, so to 230 volts. The current design, which we are bringing, is using the IPT prime of Z move design. This is this particularity of the pad having the ability to come up and near to the car surface. So on the right, on the left, you see some of the on the right you see some of the complexities you have without this approach, and in the left you see the advantages and the advantages of having this Z mover. Most of the advantages are thought in order to facilitate the first adoption, bringing in a more universal solution with higher specifications for a quite big improvement in the final price. So in here, for example, with the Z mover, you will be able to charge any sort of vehicles independently if it's an SUV or a sport car in the high, because the Z mover will move to the surface. And it will also let you have only one type of coils for all the vehicles. You will be always have the same efficiency no matter what type of car you have, without making an extra development for a different car. So you will be much more standardized for all the cars. Also with this, as I mentioned before, the positioning function is quite important to be optimized. And in this small equipment or device that you've seen, there is a positioning function that will be prepared to be implemented in autonomous vehicles with accuracy, which is here you can see the graphical accuracy according to the distance to the vehicle. But if you see when you are lower than 1.5 meters, you are having an accuracy that is plus minus 5 centimeters. So making this positioning very accurate in order that if a system has to park the car, it can be really park it to the centimeter. Another very important point that has been developed and is not the one that is the most evident is bringing a system that it can detect metals in order to avoid any heat of materials, because when you have magnetic fields, of course, you have to take care of some safety features or figures. You have to know that with the magnetic field, any surface can get a little bit hot, and the smaller is the metallic part, the hotter it can be. So the system comes with a MOD, metal object function, that will be detecting the metal and prevent the user that the car is not charging for this reason. So, but in order to be more graphical, I would like to show you a small video which will be explaining also much better all these functions. So, Fraser, if you see that it's running or not.
The Z-mover, a charging system that ensures optimum distancing between transmission coils at any time and the greatest possible efficiency. The Z-mover also allows for the design of a particularly small and light vehicle coil assembly. It already contains all control, communication and current conversion components next to the wire and ferrite of the coil itself. The same coil is compatible with all vehicle heights, an important factor for the commercial success of the system. Simultaneously, we were able to significantly reduce electromagnetic emissions to a level that is far below already very strict legal thresholds. More precisely, the Z-mover's electromagnetic stray field is 3 to 6 times weaker than that of charging systems without moving parts. To ensure that nothing can interfere with the Z-mover's moving parts, the same secure pinch protection used for automatic window lifters is built in. Naturally, the system is perfectly equipped for outdoor use. Thanks to robust materials and a comprehensively tested, frost-resistant mechanical system, the Z-mover performs. Come rain or shine, even at temperatures as low as -25 degrees Celsius. During the charging process, clearance is monitored by high-precision metal detection. This identifies any object that may heat up due to the induction field and reliably interrupts the charging process when applicable. In line with the development of autonomous driving systems, the PriMove team has developed a special positioning system through which charging plates are approached easily. Automatic parking and wireless charging become reality with the PriMove Z-mover. Automatic, efficient, safe.
So I think this video has the beauty of showing much better than any other words how the system functions. And I will say this is a good introduction to let all our public to understand first how is the wireless system functions, and then an introduction for the project in user C and the activities we're leading in Barcelona together with the AMB.
Great. Thanks very much, Sergio. That was very insightful. So now I guess we move to the questions, and I see, as we're not so many in the session today, if anyone would like to come up onto the stage to ask a question, they can click in the top right-hand corner, request to share audio and video, and they can come up and we can have a bit of a face-to-face discussion. If not, I would like to maybe kick the questions off to Sergio, and I've got a question regarding this. At the moment, is this product highly scalable, would you say? Could you see this as a solution in cities across Europe, or is it still a bit in its infancy at the moment?
Well, the first adoption that can be really quickly scalable, and the first thought of this product is to have it for all the private that have in their car, in their house, a first solution to just come and park and leave their cars without having to think about anything about the charging. And the second generation will have systems that might not have this Z mover in order to be flat enough in all the parking lots. But the technology, of course, is versatile enough to make this change quite easily, also to scale up in higher powers in order to be able to do in shorter time other types of charging.
Absolutely, and I suppose with the progress of sort of technological advancement with electric vehicles, do you see this sort of thing becoming more commonplace within 5 years or so?
Of course, absolutely. We are already also thinking on all the constellation that has come with it. The best world I could imagine is a place where with the same equipment you can drive on the highway, for example, and then you can charge while you drive. That means with an only one equipment, you don't have anymore the need of such a high battery, because on the road you will find your extra charging without even parking, but just by driving.
Yeah, I was just about to ask that question, funnily enough. Will we be living in a sort of, it seems almost sci-fi, where you'll be able to charge your vehicle as you drive it. But so you really see this as a possibility in the future?
Yes, indeed. We have, with these technologies we have in IPT and the one we took from Bombardier, in fact, there is some tests done, and this is a technology we have and where I worked through 10 years. I personally have done most of 4 laboratories and also in real field installations about dynamic charging, where we were able to transfer 160 kilowatt, so quite much higher power than what we are talking here, during the driving of a truck at 80 kilometers per hour. So this is a reality we could make happen in any time we get the right stakeholders into bring it forward, with always behind 2 things: the user's comfort and the environmental aspect of taking out the batteries and having the same autonomy that we have today with our present cars.
Absolutely, absolutely. But I suppose it's we can only wait and see. I mean, 10 years ago,
Yes.
what we currently have was probably still unthinkable. So it's probably on the horizon. We have a question from Lucian Zagan, who's one of our colleagues at Eurocities. He'd like to ask, what is the main barrier in implementing this technology at the moment, and what needs to be overcome to have a significant take-up?
Well, this is a very good question, and I think a little bit over only the domain of IPT. Of course, we need the right stakeholders, as I say before, and looking very carefully about all the elements that were just mentioned in the main discussion, where you can have troubles in the standardization, for example. This is very important to have a standardized system. Okay, today we have a system that is bringing the technology with a standardized frequency, for example, which is very important for the interoperability. But all these things has to be spread more the world and developed also by all the stakeholders, not only the ones which have the technology ready, like we have, but also the whole society, I would say.
Okay, excellent. And also a follow-up question. Who would be the immediate targeted clients? I know you mentioned that you're sort of looking at the private sphere at the moment, but do you think you'll be able to quickly move beyond that into sort of public authorities and administrations?
Yes, in fact, this system can be quickly adopted in any fleet. For example, if you have share cars and you have your parking and it's clear, because this system, I would say, has having a Z mover had some parts of the concept that might be have to be adopted and adapted in some certain application. So you need a step forward to go to vary all kinds of uses in the street. So like I would say, I would like to see the malls coming and having in their parkplace this system. So you have your own in your house, and you come to buy your things in some mall, and you can park, and there is a place to park and charge. But you can do it very quickly today, as the question is this one, into fleets, for example, taxi or sharing cars, apart from the private cars. This is something you will be able to do already with this version we are developing here with usership.
Excellent. I think that's perhaps a good segue onto Silvia Valero from Barcelona, down on the sunny Mediterranean coast. And I think you're going to tell us a little bit about the applications of this product in Barcelona, and I believe you as well you're testing it out with some of your the fleets of IMB.
Exactly, Fraser. Thanks for inviting us, first of all. I'm Silvia Valero, technician of the Department of Sustainable Mobility in AMB. I'd like to share my screen to share our feelings of this product, of this Inducar product. Wait a second. So I guess you can see it.
Yep, all good.
Good. So first of all, I'd like to present a little bit who is AMB, and later on we're going to move to a more specific detail on this implementation of the product of Inducar. So, well, located in the northern east of Spain, we find Barcelona as the capital city of the region of Catalonia. Barcelona and its metropolitan area centralizes 36 municipalities with approximately 3.2 million people. Just for information, AMB is a local administration that gives services to these 36 municipalities and has approximately 700 employees. As you can see, AMB has competences in various areas, such as territory, environmental, economic development, housing, and social cohesion. But the one that has the highest economic importance is the transport and mobility. In particular, our superior of sustainable mobility is in charge of promoting and implementing solutions to encourage the sustainable transport. This specific area has been growing over the last years, trying to improve the air quality of the cities in the metropolitan area and reduce our impact in the climate change. So as part of our strategies to encourage people to move in a more sustainable way, AMB is promoting mobility. We try to be updated with the latest technologies related to this electromobility, and try to improve our services to the citizens. That's why we decided to participate to usership. As a demo site, our main job in this project is to provide the space to test these products developed by the project, and also provide users to test them. So going further in the Inducar project, let's say this is one of the products that will be shown in AMB. Our vision of the inductive charging has two main aspects on our interest. The first one is that AMB nowadays manage the public charging infrastructure in the metropolitan area. Nowadays, in these 36 municipalities, let's say, we have two public operators of this charging infrastructure. The first one is Andolla, Barcelona, which has 60 charging points in the streets, and in the metropolitan area of Barcelona. We have it's AMB, who is the manager of this public charging infrastructure and has nowadays 10 charging points, but it's actually tendering the construction of 50 new charging points in 5 years. So this is quite enlarging our infrastructure in the metropolitan area. So we are operators, and the actual situation of the charging procedure of our users, it's have some problems or has some issues, such as the deterioration of the moving elements, as Sergio mentioned before, and the vandalism. All these hoses of power supply are also a problem because of that, deterioration, vandalism, etc. We think that this inductive charging can be a solution for the future for us, for the charging point operator, to improve the experience of this charging procedure and make it easier and less vulnerable and with less maintenance. On the other hand, there's another aspect where IMB is interested in this Inducar product, is related to our fleet, as we mentioned before. AMB's actual fleet has approximately 45 vehicles, 65 of those as 100% electric. And we have, as you can see some photos of our fleet, we actually have a parking, a covered space, and it's already electrified. As you can see in this photo, this is our actual parking. You can see Inducar can be a good opportunity to avoid all these messy cables and to make the charging procedure easier to our colleagues. So how we'll be doing this test? How are we implementing this product to test? First of all, we have to say that, as also mentioned by Sergio, there's a small modification that we have to do to the infrastructure to make possible to install this product. As you can see, here it's an example of an easy of the modification of the infrastructure that we have to do to install the product provided by IPT and to try it. Hopefully, we will be testing this technology with 2 cars that we will be providing. So we will be providing and modifying. And also, we will be testing this product with employees from AMB, colleagues from our department. At least we will be trying to do it with 10 employees during these nearly 2.5 years that are left of this project. Finally, there's a good point, as there was a question about this before. The requirements and considerations that we have to take into account is that the car will be modified by a system that it's not certified still. So we need permits to drive these 2 cars that we will be modifying to be able to go to the route and to drive them on the street. And also, we will have to consider a special insurance for the workers that are driving the car. As it's not a standard car, it's a modified car with extra equipment. Once this is implemented, we will be showing the solution to our colleagues in AMB, but also to other authorities that have fleets of electrical vehicles, and also that are CPOs. So to sum up, I can say that nowadays, as mentioned before, the charging procedures in public and parking spaces are a challenge because they are isolated and sometimes unsurveyed. So they are in the urban context alone. This means that we have issues mainly because of deterioration and maintenance cost. That's why, in our point of view, the physical interaction of the charging infrastructure has to scale down and give to the floor to the new cableless technologies as Inducar. This future can have 2 good points. The first one is the user-friendly charging procedure, and also less maintenance, less vulnerable, and make the infrastructure more cost-effective. From AMB, we believe that this Inducar product can be the starting point of new charging models that can revert in lower maintenance and to enlarge the free public charging infrastructure. cable-free public charging infrastructure. So hope this presentation gave you a little bit more the idea of AMB's interest of participating in UserG and also to test this Inducar project. Thank you very much.
Thank you, Silvia. Very interesting. And now I guess we have a few minutes for a few questions before we return to the main stage. Again, if you'd like to ask a question, you can request to share the audio and video and join us on stage, or you can simply post it in the chat. But I guess I could start off with one for Silvia. So what sort of scale do you imagine for inductive charging in the metropolitan area? Do you one day perhaps see it as becoming the dominant form of charging over charging posts with cables, for instance?
Well, actually, we were talking about this today. The problem actually that we have is that our charging points for 3 vehicles, it's a problem because of the cables are short, and so it's difficult to get to charge to all 3 cars at the same time. So maybe we could think that a good scale-up would be like, or maybe an hybrid solution, or have more points next to it which are inductive, that avoids this problem that we cannot have more than 2 comfortably plugged in cars, but have more. So I guess for the urban area, I think it would be also a good solution.
Mm-hmm.
But also the easiest way to test this is in our fleet. So with our general services, we have been talking about this project. And why not after the test, we can talk with Sergio if why not enlarging this solution. I mean, there are some issues that we have to solve about all these requirements, let's say, and this approval, no, to be able to drive with the car with this new installation. But once we have done this, I think it's a good opportunity for us.
Mm-hmm. Definitely. And you mentioned that, of course, you're testing it out with your fleet and some of the your colleagues at IMB. And when you're talking with them, I mean, are they all sort of like mobility experts, e-mobility experts, or are they just, in other teams? I mean, I guess what I want to know is what kind of questions are people asking about this inductive charging solution, or what concerns do they have, perhaps?
Well, we will be trying this with, let's say, with the people in our department. We have two experts more, and other technicians that also work on sustainable solutions. But it's true that not electromobility itself. So it's people that know and understand how the electromobility works. Let's say that. The specific questions, or I think that the thing that they are going to ask, or but how am I going to park this car? Am I going to have an app of the mobile, or how I'm gonna guide this car to park it? I think this would be the highest challenge for IPT to solve, and we will be testing this with these experts and more, let's say, general users. So we will have a wide variety of opinions of the system.
Yeah, do you have a response to that, Sergio? That it's hard, people will need to know how to park the car.
Well, there are many possibilities, as Silvia has said. As we are in the development project or phases, we have this possibility to go through an app, but the system is already conceived in the way that you will have a display in your normal display. It will just pop up when he sees that the charging pad is in the near. And in the first stages, you will drive through with help of this display. But in the final stage, the idea is that the car will drive alone and it will park. So all will be integrated in your car, and you will have through the display all the information you need. Possibly, you can also develop the app we were saying in order just to have an external information system, but which is not the main system in the final stage.
Mm-hmm.
Okay, great. I hope that cleared things up for you, Silvia. I guess another question I would have is regarding the situation in Barcelona. I know you touched on it briefly about standards. Is it what are some of the barriers that you can really imagine for this for the widespread take up of this inductive charging solution?
Well, more or less, it's good because it's a standard system that can be installed in all types of cars, and hope it will be interoperable. So this is good, but it's true that the modification of each model of car has to be done, and that's quite a barrier. There will be standard procedures for every model to modify them and install this product. How are we going to do this? Who is going to do this modification? There will be special technicians or that have to do this. Later on, how are we going to get approved to install this system? So I mean, there's still some things that we need to figure out, but I think we are going on the right direction with this testing that we will be doing. We will find out how to legally drive with this car and how we're going to implement this with all the stakeholders that we have involved.
Excellent. And as I said to Sergio just before, the speed of change these days is so quick that who knows, in 2, 3, 5 years we might this might be the standard, and we'll be driving around on highways that will be charging our vehicles as we roll along. Okay. Well, now let's move back to the main session. So I'd like to thank Silvia Valero from the Metropolitan area of Barcelona and Sergio Perez from IPT. Thank you both, and I'll see you back on the stage.
Thank you.
Thank you.